Okay, we are back live. It has been a heck of a few days here. Pokemon results is finally out. We've got the Hacker News post, and it is also on X right now. So come check this out. I'll answer some questions on here probably if people jump in. But for the meantime, we have two main things that we need to catch up on today. A little bit of porting work for some collaborators, and we need to, oops, let's not leak that. Hang on, let me just flip this so I can move that. Close all the boring windows. And there. Okay. So the other thing we had to do is look at the new ablations and figure out what is going on with these. Actually, I'm going to just drop one thing in Discord as well. Let me just drop this in. So I figure this is funny. This has been taking up a lot of spare time lately, but we finally got this put together, so. Cluster, garage, gym setup. Happy with this. Anyways, what we're going to do today, first thing is going to be to figure out some stuff with the experiments that I haven't had time to do lately. And then after that, we're going to have to do some porting of some of the optimizations we came up with. So let me see here. We have, this is the current best Pareto front on Breakout, right? And not sure what this is. I think I was just testing some stuff here. Close this. This 200 run is our best, and then 187. Okay, so this is, I think, before we made the perf enhancements. We were at 200 seconds for solve. And now what? Okay, we've got these runs. Okay, so these runs, this is a 180-ish, I believe. And then these ones are 220. Is there any difference between these? I thought I literally just ran the same thing. Twice. Let me go double check on that. I believe this is, oh, this is still going. Hang on, if this is still going, it shouldn't be, right? Okay. How is this possible? It gets up to like 800. 800 cost. This one's also It's up to 800 cost. And this one's cheaper. Maybe it just takes a while longer. I mean, it's not fully optimized yet. But then why are these qualitatively different? They are qualitatively different, right? And I'm visualizing the wrong ones. This is our previous best. This is with 187 samples, okay? So this has had more time to optimize. So now the difference that we're interested in here is the 118 versus 127. So with 118, we're getting some solves in the 180s. And then here we're at 250. That does seem odd. Okay. Is there any difference here? Your branch is ahead by 2 commits. Oh, this is not auto-scaled. Okay. This is with a manual scale. So this actually does have some substantial sweep differences. Cool. Already up to date. Put this here. Put this somewhere I can get to it. All right. No, I have this auto scaled. I'm confused. What is in dev right now? I think we're going to want to have auto scale in dev. Okay, we do have auto scale in dev, right? Oh, I see. It's gotten desynced. So we're solving, but it's taking way too long. This is silly. Yes, I did just delete the repo and reclone it instead of bothering with it. we will leave that, and otherwise we'll just delete all these scale terms. Now we still have some issues here, right? I want to see, not this one got screwed up, right? We have 187. Auto scale P3. Oh, okay, so we want this. This is one comparison. It's the other comparison here, right? I believe this was pre-optimization though, wasn't it? So we have, was it 192-ish here? About here. There we go. So slightly faster, but it's also fewer runs. So we expect this to come down even more. And we go to, I think, sample. I want to see what the SPS is looking like. Yeah, okay, so there's this massive gap, essentially. And I want to understand why. So we have mini batch of 8192 here. This thing is still using 2 small mini batches, which is further slowing it down. Okay. I think what's just happening generally is that there is more overhead in the new algorithm branch because it's not as well optimized, which is then preventing the algorithm from taking advantage of larger batch sizes and stuff because they cost more, and then the smaller batch sizes are also slower in wall clock, so you're kind of just screwed on multiple different angles when you have that. So I think what we want to do here is we want to actually evaluate speed differences with some reasonable settings. Yeah, let's do that. If I want to do this on box 0, on my local. I think we'll do this on my local so I can play with it. By the window go. Count, lower the train. So, no CUDA GPUs available. Lovely. I gotta reboot my container, I guess. Happens once in a while. Okay. Puffer, breakout, load, train. Okay, so here we have our default puffer breakout parameters here. These are not the parameters that I think we want. So what we should do here, there are a few things we should do. First thing I think we want is did I already do it? I think I might have already done it. Batch size. Gamma. Yeah, I think we need to comment all this. is slower. And then we do these ones. What's happened when we do this? Yeah, this is still nowhere near as fast though as we're expecting, right? We're expecting even faster. Or are we not? I think we should be. We take like 21414. Let's try 21414. I really have to make a better way of copying hyperparameters rather than having to do it manually. How is this one? Hang on. I'm confused here. So this is 94 seconds, right? Oh, it is almost 1,000,000 FPS. But then something doesn't add up here, because if you can get how about 21536? Okay, it's a bit faster, right? And it probably has more M's. 2048 M's. Chart look like. Oh yeah. Very clean. It runs for more steps, I see. I thought I set it max though. Maybe these are eval steps. Okay, maybe it's slightly different. Cool, this is fine though. This is 106 mil. So 1024 M's. This is not the previous run though. I think this is a new one. So we'll just copy these parameters. And this should give us 94 seconds, is it? 94 second solve. The other one's kind of better, isn't it though? Yeah, 84. I think we'll do this one instead. This one's pretty cool. It'll also let us test overhead a lot better. 126. We'll give it 130 mil. So this should be sub 90 second solve. Luckily, this learning rate doesn't matter. This is just whatever. Should double check on that at some point though. Okay, larger batch size, which is, you would expect a larger batch size, right? 32 horizon. Entropy is higher, just a little bit higher. Pretty close to default, actually. We do need lambda. Surprisingly pretty close to what you would expect by defaults. learning rate 006. Mini batch size. And I can confirm that these are way closer to hardware optimal settings. But 2 update epochs is why it gets slowed down. Two update epochs is why it is slowed. Let's get rid of this. And 2048. Okay, so let's see what this does. Very smooth learning. Very smooth learning. 1.1 mil. Just a little tiny bit slower than anticipated, but still very good. Definitely within what we would expect. All right, perfect. Now we can compare this one. Uh-oh, are we gonna have instability here? Oh, okay, it's good. Why is it so much longer? This is 2 minutes now, right? Maybe I gave it too many steps. Hang on, yeah, I think I gave it too many steps. Maybe it wasn't 130. 126, but yeah, this is not going to be a... Yeah, it's 100 mil, not 130 mil, that's why. It does solve, you can see. But then we will do one more just to see if we get confirmation. So, okay, we did this. This gives us 862, yep, solved here. And then we'll see if this makes any difference. There is expected to be a little bit of instability, so if it doesn't fully solve, if it gets stuck like somewhere, it's within reason. We'll end up having to do like average or something, like seed average. And see the amount of variance. Okay, this is much better. This is a lot closer to the original solve time. There's a slight difference in the train speed, I believe, here. See? We also actually have decent env overhead now. It's worth fixing. Definitely going to be worth fixing. Not this one. $1,100. Okay, yeah. So there's like a 10% speed difference or whatever. No big deal. I think my single core is slightly slower here, and multi-core slightly faster than the other machine, something like that. So very, very close in terms of time. 841. $856. Okay, very, very similar. Very, very similar here. Now, if I do nothing but train dot use P30 true, what happens? Okay, so what happens is that the speed takes a 25 plus, almost 30% haircut. This is 27% miss. So that's all of the overhead right there. It's probably in MISC. So we need to make that thing faster. But I want to see how the learning curves themselves compare. Mind you, these hyperparameters are not optimized for this. They're optimized for PPO, not this algorithm. But I want to see how they compare. A little bit of instability. Look at that jump at the end. Okay, so there is some instability. But without even like retuning the hyperparameters, I mean, this to me is potential, right? This is massive, massive potential. Oh yeah, that is massive, massive potential right here. So in samples, again, a little bit of weirdness, but it looks like, especially if we were to retune parameters, we are on par with PPO. But we are taking a 21% compute there. Hang on, forward, miss, comping. Mostly looks like the haircut is in MISC right here. This is very, very good, like promising good news. There's so much potential with this. I was starting to get worried that like maybe I had it wrong, maybe this new algorithm wasn't like all I thought it was, but actually I really like this is worth pursuing. This is really, really strong evidence for it. This isn't even using gamma and lambda. So this is two hyperparameters totally ignored, and there's several things I think that we could improve as well. So the first thing then with this MISC I want to do, I'm going to leave myself a good hour and a half for porting work. So I'm going to do this for another hour and a half, and then I'll leave the time after that for porting work. Actually, let me send the quick thing. It'd be major if we get this to work. Let's go figure out where the slowdown is. 28% is a lot. Take Neptune off. Okay, so we're leaking about 8% of the compute here. We're leaking none of the compute here. Pretty cool to see I have this much promise. Doesn't it add a new parameter? Net one, nope. So at the moment, kind of, because it sort of is a hyperparameter, but longer term, you just set that to your hidden size and you're done. It's not like it. So once we fix a couple weird things with how we're calculating horizons, it should end up being the case that more will be strictly better. And in practice, you'll just set it to whatever your hidden size is. So at the moment, there's a quirk with it where you need to set it small because I haven't done masking fully correctly, but that will go away. is pretty cool. What would happen? It would just work slightly better or the same. No difference. And we're leaking just a little bit of perf here, a little bit of perf there, a little bit of perf everywhere. That's very obnoxious. We just need to make it like 30% faster. Actually, you know, there's something I want to check as well, because we might even have to, I want to see how much more we have to optimize it than I currently think. So if I do that P30 horizon, how much lower does it get if I do this? In theory, it really shouldn't have much effect. Practice, it has a massive effect. Is it all in MISC though? It looks to me like it is all in MISC. You see that massive MISC overhead? So let's optimize for this case, and then we'll go from there. So we don't want to do little optimizations if we need to do big optimizations first. How much of it is right here? There it is, right here. No, 10% is in here, okay. How about here? Just like leaks, a little bit of perf here, a little bit of perf there, a little bit of perf everywhere. Really obnoxious. And then how about this block? Is this one longer as well? No, this one's actually fine. Okay, so this loss, you know, maybe we can compile this to make it a little bit faster, but it looks like we are mainly leaking perf. I think we're mainly leaking perf in here. Hang on, how is this not all of it? How is this not all of it? Where are we leaking 20% additional perf? Yeah, that barely adds anything. Where's the other 15%? There it is. That should not take any time, so let's figure out what's wrong. Buffer is going to get even faster. Isn't that crazy? Yeah, okay, so somehow this stupid block of code that should not be taking up anything is taking up 13%. That is a lot. See if it's in here. Oh yeah, there it is. Values mean I don't know if you saw on Discord, but I tried Torch 2.6 and I get a 60k speed up. Already did it, my friend. Did you change anything on the box? I didn't change anything on any of, I don't think I changed anything on box 2 or anything for you, but I did I shipped like a new dev build puffer tank files for Torch 2.6. I think that that's specific though to action sampling, so that's not going to be across everything. That's just going to be across like specific types of ends. Any reason not to merge what PR? Yeah, the reason not to merge a PR is I haven't seen a PR. Ooh, look at this. This is doing okay. Let me get that PR open. Does this work? Wait, what the hell? Does this help with your thing? I'm sketched merging that into 2.0. If you do it to dev, I'll PR it. If you do it to dev, I'll merge it instantly. Generally, merging stuff, just like YOLO merging stuff to the main branch, just makes my life hard because inevitably there's like some case where it crashes an env or something, and then I have to stop what I'm doing and like go fix 2.0 frantically before like it impacts somebody who really should not be impacted by it. Hang on. We've got lots of cool discussion in group chats now, private group chats on Pokemon. I'll leave that up to reply to some people. just juggling things with all the release stuff. It's cool. I think the post will at least do pretty well for Pokemon, which is nice to see. I think that guy will have. See, the problem is now, even though I have his name and it's all public, like it's still gonna be that guy forever because it's what the freaking Discord is. Yeah, this is awesome. Does he have followers yet? Oh yeah, he's getting some followers. He started at 0 today. It's at 45. That's a little start on X. I always say that X is mandatory for ML researchers, so. Cool release. All right. That's enough chatting for a bit. So, it's so obnoxious the way that this is. So, reward block MP. Reward block big. Reward block big. Do I really want to copy? I guess I have to, right? Now we have reward block. Now we can do the computation on the GPU, and we will not be stuck. Perfect. See if this does it. Expected all tensors. Okay, what did I mess up? Experience dot reward block. Values mean. Okay. That's annoying. Why do I do this again? I think there was some indexing crap. There shouldn't be. Shouldn't be any indexing crap. Contiguous block. I guess we just start putting stuff on GPU. We're gonna have to test a couple things. Self.actions. The thing is, these are already on the GPU, aren't they? I believe so. I don't know if this is going to be worse. I actually kind of want to test this separately before I do this, because this could be a big mistake if I screw this up. To 78 on the retweet. And mostly converting to the original as well. Okay, so this is a 1.1 mil, right? And then we're gonna try putting all this stuff on the GPU, and we're gonna see what happens. He's on the GPU as well. Where's device? Okay, that is a problem. I'm almost sure that Torch doesn't have that. I'm gonna just borrow this for now, and then we'll hope that we don't break shit. I think this will be the wrong order, but fix order. Experience has no attribute NDEM. This should be self. Oh no. Invalid for input size 3. What? That didn't help at all, now did it? And this is slow as fuck. That is so slow. God, that is awful. Why does that even exist if it's going to be that slow? I don't think there's a fast GPU sort, right? Is that a thing? Much better. We'll do this dot 2. Does this thing have a device? CUDA. Perfect. We actually do have a device. Just do like this. Dot 2, right. Let's just add then this below. From numpy dot 2 self.device. Lovely. Int, but received. Okay. Apparently, this is not happy. Let's just do BIDX is obs. BIDX is obs. The transpose function is different. This is dot permute. BIDX is. Is there a reason for this? I guess there kind of is, right? Yeah, I guess there kind of is. So let's just go back. Okay, 1.1 million still, right? Same speed as before. BIDX is dot 2 self.device. Yes, because we're indexing the same way. Great. So next, what do we do next? Yeah, reward block. 0% custom here. Expected all temperatures to be on same device. Values, mean, and reward block. Right, this is the thing that I wanted to try. Profile train MISC. So, put these on device, put these on device. Reward block numpy. What happened to train custom? Is this now faster? Oh, was this faster? Oh yeah, it's faster. Okay. Okay. Okay, so that's an immediate boost, right? Just taking this off of the, just doing this on GPU, this is now 0%. And now let's see where the other compute is leaking. I think it's all here now, right? I think 7% or whatever in the main loss function. And then the rest of it here, right? Yeah, about there, 7%-ish, 8%, something like that. Now all of our leaking, all the leak is right here. Of course, we're going to break some synchronization, but we'll have to fix that. Finally got around 2, working on graphics for Impulse Wars, added some trails for players and projectiles. Having trouble making edges of the map have a bloom glowing effect, but maybe icons for weapons is all I need to add. What do you think? And you made a website. Let's see. Ooh. Okay. Hey, these projectile icons are a nice addition. It's got something, some fancy weapon, it looks like. Where are the weapon icons? Oh, maybe I need to add those. Okay. I don't know. I mean, I still think you could come up with some sort of creative shader for this that would make it look really good. Like, pretty much all of these weapons are just going to be, like, particle effects. Like, you can probably just find some cool shaders. Couldn't find any icons? Where are you looking? I mean, there's all sorts of stuff like this. I think you want the ones without backgrounds on them. It's just generally where you look. You kind of have to do some digging around to find artists that you like, and then see like what stuff they have. Something like this also works. Not bad. Graphics definitely a pain. Oh man, we're leaking 6% just in indexing. Okay, I'm gonna have to look at this. Map should look prettier somehow. I mean, there are a lot of things you can do there, right? I mean, look what they do, right? They literally just did like, they just have some bloom on stuff with a bunch of sharp angles and render stuff using outlines, right? I think that you could probably do something pretty similar to this without too much difficulty. I mean, there's all sorts of stuff you can do, like, for instance, you can do shaders to, like, ripple the environment when shots hit and stuff. I'm gonna be right back. Let me use the restroom. I'm gonna ban this bot first. I'll be right back. We're back. 35% leak. 8% just an index in. Which means... Okay. Let me try something. Forge.CUDA.synchronize. What happens? Nothing, right? It's still going to be 8%. 70%. What if we do it like this? Slower. Much slower. Interesting. Torch indexing is slower. Maybe not. Hang on. Experience.sort training data. B IDX's obs. Maybe you just have to .CUDA them. Let's see. I remember PyTorch having this issue before, but I want to see if they fixed it since. Experience.idxs. Okay. Still a lot of data to transfer. Ideally, you don't want to do this. Yeah, still just too slow. Okay. You do not want to do this. Because this is on the CPU anyways. How do we get around this? It's a massive freaking amount of data. Why doesn't this totally crush performance with the observations, actually? You would think it would, right? Bobs of MB. That doesn't crush perf. Right? Bobs. Batch. The obs are much bigger than the values. And we have to do the same indexing operation, don't we? How does that somehow not crush performance when this does crush performance? Right? IDXs. I guess maybe the answer is that it kind of does. That's probably where most of the overhead comes from, right? It comes from this. We're just at a point where things are so fast that this indexing operation is slow. I wonder, is there a faster way? What we can do for this. Is there a fastest NumPy indexing? Where's something more modern here? It's doing what I think it's doing. I'm pretty darn sure that this is literally just here. Might be time to pay the piper on this design decision. Okay, so here we have our indices. That is rough. I mean, I guess, okay, first of all, kind of have to figure out the trajectory segments thing now, don't we? I've been putting this off for like a year. It's a pain in the ass. I guess we'll draw this out. This will be pretty informative anyways. A couple people watching. Not Draw.io, right? What is it? Draw online. Okay. So it's a blueprint. So the problem that we have at the moment, right? When we collect observations, let's do the full thing. We get indices. Like 0, 1, 2, 3, 4. Okay, and then this is at time t. And this is the environment index. And what's the other thing that we store? I think that's it, isn't it? Oh yeah, we also store a flat index. So the sample order. So what we do with this is we go 0, 1, 2, 3, 4. Actually, let's just make this clearer. So let's do, instead of zeros, we'll do 1, 5, 3, 7, this. Set time set t. Okay. And then just do like, we get like, what's it, 0, 3, 1, 4, t plus 1. Okay. Now, when we store these, we make a big table like this. And now this has 8 numbers, 0, 1, 2. I guess it only goes up to 7, huh? 7. And then it's going to have the environment index. So this is going to be 1, 3, 7, 0, 3, 1, 4. And then if we put up the end, we put t, 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 t plus 1 plus 1. Okay? And then what we can do is we can sort this thing. We can sort this thing basically by, I believe it's this row and then this row, right? Yeah, we sort this by this row and this row. So what we want to get out of this is batch of data at the end of the day. So we get what we do 0, 1t, 0, 1t plus 1. We do I guess it should have been 0, 0. Why it's so confusing? 0, t. One. We do 0, 3. T plus 1. 0, 4. T, 7, T. Okay. So now we have these in order by environment ID, and clearly the important thing here is that these are grouped up, right? These are grouped up. So technically, if we keep these indices, we should be able to detect these boundaries and use this. It's still tricky because with the LSTM, you have to go across bounds, right? So I mean, we split this up into segments. Oh, but the key assumption here is that the segments are going to end up being pretty long, right? At least reasonably so. I think if we just pass this indices array, the sorted indices array, I think we get it, don't we? Oh, and I messed this up as well, didn't I? Is there an eraser? Yeah, this should not be like this. You have to actually arc sort the indices. So, what is it? This is actually 4. This is 0. This is, am I stupid? 0. No, this is fine. 4. This initial 1 is 0. This is 6. And so on and so forth. So you do have the indices in here. The indices tell you where to get your data from. How much of this indexing is coming from each of these other things? Much of this indexing is coming from each of these other things. Like, can I just do this? Like, is this expensive right now? Still expensive. That's still 11% compute, 12% compute. It's a lot. What is this doing? Okay, this is not doing very much either. Still a lot of compute. I mean, we can't do this on the GPU, right? Now, there's iteration here. That actually screws us over for the values as well, doesn't it? It does. Very difficult to make this thing fast. But should it be? It shouldn't be, right? The observations in the network are doing way more work than this. So it's really just about optimizing this thing, because the fundamental amount of work being done here is not very large. Kind of a few different problems with how we're doing this, isn't there? Aren't there? So there are a few different problems. This is driving me nuts. Kind of want to solve both of these in one fell swoop. All you have to do, you're looking for boundaries, right? What are my options here? I already have, do I have all these quantities on the GPU already? Or do I not? I have everything but the index tensor on GPU, and the index tensor needs to go to GPU anyways. There's no way to store this stuff contiguously in the first place, right? No, you'd have to make additional assumptions. How many additional assumptions would you have to make? It's kind of tough. Like, me supporting the full asynchronous is starting to limit the ways in which I can collect data. Right? For something like GPU drive, you're going to get all these little segments. You don't know from the get-go how you're going to want to batch. So the best thing you can do is store them flat to begin with. Right? I think I kind of already have the optimal optimal thing here. Don't I? I mean, how else would you do this? You could have a per agent buffer. That doesn't help you though, because there's a max size to that. That can be highly variable. That can be highly variable for every type of env, usually, not even just for specialized ones. That doesn't help you. So yeah, you can really only... Hang on. Each environment. No, you really can't improve on this very much at all. What this indexing operation that has to happen. You would think this operation should be able to be fast. Forge fast, fancy. I think we need to go check this out, don't we? Okay, let's just go get some data. So here's our data. Quote. False. That's speed. What I can just do. Watch that CUDA synchronize. Hold on, is there a substantial difference here? About 2x. It is. Let's just make sure there's not a bias. Oh, I'm stupid. Hold on. How about we not be stupid about things, huh? Same speed. We'll make sure, but yeah, that's fine. Same speed. Hang on, is this something? Is this flat? Viewed as 1D tensor. Ah, that's why. I think that you're unlikely to be able to improve this, right? It should already be parallelized efficiently. So nothing you can really do here. Oh, NumPy takes forever, huh? Interesting. Doesn't matter if you use an int or a long, it seems. NumPy indexing, very, very slow for large tensors. If by comparison, though, if we did this, would the results be different? Yes, they would. GPU is faster for large tensors. It's slower for small tensors. What about this? Okay, that is interesting. So, with big batches, it is faster on the GPU by an order of magnitude still. It goes down if you have smaller batches. This is still faster. What do I do with this information? I have some ideas. I'll be right back. I'm gonna keep on this for a little bit here. I think that what happened with this is before I was measuring indexing for them, and I had smaller batches, so it was more effective to do it in NumPy. But now it's faster to do it in PyTorch. It looks like. Oh yeah, what if we do? Hang on. What if it's not good? fast these go. Ah, this was the kicker. So they still have this problem, it looks like. Maybe not. It's actually faster. It is actually faster. And index select is faster than splice here as well. But it's not that. That is not the case for majority of these. So let's just do this one real quick. It's 4. Okay. Torch has cleaned up their indexing a whole bunch. It looks to me like Torch has actually improved their indexing a whole bunch. So we can possibly rely on that. $650K, right? Sample logits. Device. Then you do store, right? We just do this. We do this. We don't have to do any of this stuff. Okay, what's this do? Oop. Return action. You're done. I'm fine. You do have to pass actions back with CPU tensor. Float has no attribute item. Aha, we get speed increase. We do get a speed increase here. So we will see what that is from. I think that is good news. Okay. How's the post doing, by the way, on the Pokemon post doing? Is it done for tonight? 95. Not bad. Definitely not bad. Few new followers as well. Mm-hmm. 34% misc, right? .np. And then actually, I think we can delete all this, right? Doesn't need any of this. Oh, that's way, way nice, right? Yeah, that's way nice. Advantages NP. I think we still need that one. But otherwise, reward block. Yeah, I think that we still need these, but the rest of them are gone. So we get rid of this. Hang on. We do need to know. We still need to have buffers allocated, right, for non-blocking, copy, other. Is there a way to cut the memory allocations out? We can look at that potentially after. I think we'll just do this for now. So I'm sure this breaks. Duns NP. We do duns of indices. Duns NP. Okay, about the same. We now have 28% of this overhead inside of custom. 28%. How do we do here? We now have this index on GPU. We need to do torch. Synchronize. Lovely. This no longer takes any time at all. this indexing. No longer takes any time. So we are making forward progress here. Just this transfer, how much does it take? So let's just do forward to the synchronized. I think we need it here for a device transfer that's blocking, but okay, so this here, it's 13%. 14%. So this is a lot of compute right here, right? Let's try this. What about this? Aha. That is faster by a lot. Frickin' PyTorch. See something? Nice. Nice. Fine. Probably doesn't do anything, right? Yeah, no, that doesn't do anything. We can just leave it as a string. It's a single call, it's not in a loop. It's not going to have any overhead. There we go. So 3% total right here. 3% total. That's big progress. Okay. Now how about this? This is 15, 16, 10. A lot of compute wasted here. A lot of compute wasted. How about flattened batch? How about flattened batch, right? Noticeable. Small but noticeable. Mostly, but mostly now we have it down to this. We've gotten rid of a lot of the overhead. There are a couple of problems here. So this is just too much data to process, I think, on this is just too much data fundamentally to process on a CPU, isn't it? Let me think. Is this too much data to process? Should it be? Should it be too much data to process? What type of steps per second do I think I should be able to get on this operation? 128 numbers. I do this all the time for PufferLib's environments. And I'm able to get this at millions of steps per second. There's no way that this is slower than Breakout. That one's like 10 million steps per second. The problem is it's done synchronously. So even if I get 10 million steps per second, yeah, that's still going to be rough. Like this end here is 10 million steps per second actually, right? That's still going to be rough. Okay. What other options do I have? It's a blocking operation. I actually need to call CUDA synchronize here for safety, right? Howdy. It's tough. I think you've probably seen by now the Pokemon stuff is live. There you go. There you go. He's probably gotten some followers, right? Yeah, there we go. 73. Perfect. What do we do with this? There's no way in hell we can do this on the GPU, right? Unless I write a kernel. Hold on. Hold on. Does it even make sense to do that? Wait. This might be the thing that finally makes Puffer need a custom kernel. This thing is going to compute advantages. The size of advantage is how big is this thing? Yeah, this was a kernel, I think. I think this is finally the thing. I've not actually done any CUDA. I've not done any CUDA at all. I mean, this is also kind of a really bad time for me to have to pick something new up like that. I'd like to, actually. This is a really bad time to have to do this. With all the other stuff going on. Let me think what I can do in the meantime. Well, I'm not totally screwed here, right? Hang on, I'm not totally screwed. This is the pessimistic case. Right here. If I run regular breakout right now, what do we get? Let's run. Where's this? Experience has no attribute. Returns. The advantage be valued. Returns. Try this. Okay, that's a little faster than before, isn't it? Just a little bit, but it is just a little hair faster than before. Just a hair. Now what? Now we check 32 horizon. It's a much smaller gap than before. Close it a little bit more. 2 M's, 2 workers, 124 M's per worker. A little annoying to have to use back multiprocessing. Million. That's slower than before. The hell? That doesn't make sense. Right? No. That does not make sense. One. Oh. I see. One point 4 mil. 1.1 mil. Let's look at the distributions here. Forward, 0% S. P, trans, 59%. Nine percent misc. 20% misc. Spend the extra time to learn. Yeah, it's just a little bit of overhead. 10% here. We have a bit more than 10% overhead, which is a bit concerning though, right? So let's just run these both for 30 seconds. I'm going to run them both for 30 seconds. And we're just going to do a little bit of just janky manual profiling. Same thing here. And then we'll compare. So we spent 5 seconds in forward, 6 seconds in forward. 4 seconds in copy, 3 seconds in copy. 4 seconds in train, 18 seconds in train. Forward is 4 seconds, 13%, 3 seconds for good. 10 seconds in learn, 11 seconds in learn. Misc is 3 seconds, 2 seconds in misc. We spent just 3 seconds in misc, 6 seconds in misc. This would seem then there's only 10% overhead. So why is it slower than 10%? 21 seconds in train. I don't see anything else it would be. All just about matches up. So I guess we'll just have to fix that and then we'll see. 6 seconds. Same thing now with Neptune. Very good. Uh-oh. Well, this does way worse. Let's see if I've broken data or if it's just the parameters, the double number of M's. This is very fast now, though. I don't think we can have completely broken learning. That is still doing something. Maybe. Processing off. 2048 M's, 1, 1. Do this for comparison. That makes a huge difference, doesn't it? It's crazy. Pretty small speed increase versus what I had before on this, but still noticeable. And this one matches, right? Yeah, this one matches very nicely. So now the only difference is P30 also, I believe before it was, we can see the SPS. We can see SPS. Okay. We'll see the SPS difference. So, yeah, we took it up from 700K to over 900K. Same code. Pretty well. $700 to $900. So we've mostly closed the gap. Oh, we should run this just for the heck of it, though, just to make sure we didn't break it. It's looking similar. Another 14% that we can save off the environment if we get a bigger end batch size working. Or lower overhead bindings. 14% is kind of surprisingly large for how fast breakout should be. Okay, yep, similar dynamic to before. D8, perfect. Boom, matches. Let's see, what did we just squeeze out of this thing? Oh yeah, we squeezed a little out of it. Extra 5%. An extra, what's this, like 30-ish%? 5%. Very nice. Is it 900K? 900K. Not fast enough. 900K too slow. 900K is way too slow. Time is it? 5:18? 5:18. Maybe I just fiddle with this a little bit. I can throw it into Grok to just see what it would do. I have no experience writing kernels. I've been wanting to get into that at some point. I mean, I do plenty of low-level dev, right? Right? Basic. Okay, you have a kernel. And then you write a little Python wrapper. Okay. Is that it? It's not that bad. Extern C. Dot X. Block IDX. So presumably okay, these are provided by CUDA. Interesting. Ah, I see actually. So this is a problem because if you don't have a GPU, it doesn't run correctly. Okay, there's no fallback. Compile both. This is interesting. Okay, so let me look at this function. Like this. All right. Oh wait, do I have profiling on? Hang on, I just saw that. I just saw the profile decorator. Custom is lower overhead here. But still there's a problem. Is this fully parallel across? Hold on. I think it is fully parallel across rows, isn't it? Almost fully parallel across rows. Yeah, because the min and the max I can compute. I can compute these cleanly. Yes. This code actually doesn't look that bad. This looks fairly similar to what I'm doing already, which is kind of what I figured. You have to be a little careful with the parallelism, and I'm sure debugging is a pain in the ass. Well, debugging's already a pain in the ass for what I'm doing. Yeah, this was kind of what I was expecting though. Like, when you're already doing low-level dev, it doesn't really matter if it's like you're doing CPU or GPU or what, like, you're using really the same stuff. It's 527. What do you guys think? We write a CUDA kernel? Or we attempt to? Never written these before. I mean, this would be kind of cool though. I think we do it. Use the restroom one more time real quick, and then be back in a minute. We'll have a good half hour, 40 minutes, I think. Let me just double check on, because I do have to go to dinner at some point. So let me double check on that, and then if I have time, we will write this kernel right now, and if not, we'll write it later tonight or tomorrow. All right, be right back. Bye. All right, I got like 20-30 minutes to just start on this. I want to make this as easy on myself as possible, though, before I start. So what we're going to do, float PD max, min, and max, okay? PD min. Let's do this on GPU as well. D min, D item, max item. Okay. We just do vstd min, vstd max. Okay. Oop. Heck. Float. There we go. Yeah, that's about the same speed as before, as it should be. So good. Now we have thing. Did they do this in the first one? I bind 11. We need pi bind. Implicit binding, okay. Okay. I see. There's an implicit bind, that's fine. And page.c. I'm gonna have to check all this mess, I'm sure. Okay. This. Synchronize. What? Let me try this. Just return something. It does. Reward block. Reward block. Buff. Guns. Hold on. Rewards. Advantages. Down zeros. There we go. Experience bounds. We also need bounds. Basically, all these are going to go to CUDA, I guess. Horizon. And you don't have to pass this because you compute this in the other function, right? Compute advantages. Advantages equals advantages CPU or whatever, something like that. And CUDA synchronize. Okay. Now we'll be able to fix a lot of this as well. Fiddle with this. And you don't have to compile this or anything, it just loads. see. Error building extension. NVCC not found. You need CUDA. You need CUDA toolkit, don't you? That sucks. We can do that for now. We can do that for now. I think it's going to be easier to just get the container. How does PyTorch ship these so that they're pre-built? I don't know, actually. But we are going to have to deal with this. Oops. Hi. It's fine. Cool. Kind of annoying that we'll have to redo some setup, but it's fine. CUDA runtime. We can go back to 12.4. Where's the darn list of them where you can find these easily? I guess I just swap it to devel instead of runtime. They're not that big of there's not that big of a size difference, is there? Oh no, there is. Adds a couple gigs, that's annoying. We should have this in our container anyways, though. I've gotten burned by this before. I don't know why I decided to get clever. Base. So we'll just fiddle with this for now. And I'll come back later. I'm going to have to do a little bit of porting stuff, and then we'll go from there. I'd say we've gotten like reasonably decent performance on first day tweet of Pokemon, 107, 5.7k views. Has it done anything on here? Nah, sadly. Sadly not. What happens? Honestly, I could see myself just jamming some Kuda on some point here. Wouldn't that be funny if we just like ludicrously optimized? We like figure out what puffer model we like to use for everything and we just ludicrously optimized it. 10 million step per second training. I think for that we'd have to literally like, yeah, the whole training loop would have to go to CUDA though. It's the thing. Any of the Python looping is just slow. I don't think it's worth the effort to really do that though, because very quickly our models are going to get bigger. A little bit bigger, not even huge, just like as soon as you go to 1 million. Maybe there's still performance benefits, I don't know. All right, and then it's puffer depths. Puffer depths, right? 15. This is a quick one. Fun. We break, oh yeah, 7,000. Look at that. That's kind of nice. Alright, there's Puffer Depths built. I should have done this a while ago. Basically, all I want to do for right now is get this container to run and then see if we have NVCC. Make sure we get something. Yay, we have NVCC. Check out. Ooh. Train. 3. Oh, great. Dynamic does not define export function. C advantage dot C U. Okay. Get my plugins back. There we go. All right. What's this do? Does that run something? Hmm. Cannot access advantages. Don't need IDXs either. ND array has no attribute is CUDA. What did I screw up? Then I gotta go. This is CUDA. This is CUDA. Stop up. That should be on CUDA. There we go. Try that. Oh, there. Incompatible args. Oh yeah, also we forgot to do, well, the min and the max are backwards. Let's fix that before we forget and have hell to pay for it. The following arg types are supported. Tensor, incompatible, hang on, what? Incompatible function arguments. All right, I gotta run. I will fix this after dinner. For folks watching, if you're interested in all the stuff I do, you want to get involved with RL, you're interested in Puffer, everything's on puffer.ai. Star the repo to help us out, really helps a ton. Join the Discord if you want to get involved, and follow on X for more RL news and content. Thanks, and